Today we are going to be working on trigonometric ratios. So the reason why trigonometric ratios work is because of angle, angle, angle similarity. Because when you have a right triangle with a set of given acute angles, it is similar to every other triangle with those same acute angles. So trigonometric ratio compares two sides of a right triangle. Remember that a ratio is something that compares two numbers by division. And in this class, we typically use fractions, and that's what we're going to be using for trigonometric ratios. So we have three trigonometric ratios. We have sine, cosine, and tangent. We abbreviate sine as SIN. We abbreviate cosine as COS. And we abbreviate tangent as TAN. So it's going to be really important that you label your triangles today, just like the rest of the unit so far. Across from your right angle is your hypotenuse. Always start by labeling your hypotenuse, because that one doesn't change no matter what kind of right triangle you're in. So then we're going to deal with sine. Sine is our opposite leg over our hypotenuse. And what I mean by opposite leg, opposite is opposite the angle. And I don't mean the right angle, I mean the angle that we're looking from. So if we're looking from angle A, opposite angle A, across from it is this little a. So this is opposite angle A. And yes, you do need to label which angle it's opposite from. So the sine of angle A is the little a over little c, our opposite over our hypotenuse. Now if we're looking for sine of angle B, opposite angle B is the little b. So again, I'm going to label this as opposite angle B. And the sine of angle B would be little b, again, over c, because c is our hypotenuse. Then we have cosine. Cosine is the adjacent leg over the hypotenuse. So adjacent means next to, and specifically next to the angle that we're looking from. So if we're looking for cosine of angle A, we're looking from angle A. So adjacent to angle A would be this little b. Now, notice I didn't mark anything else on hypotenuse, because the only thing the hypotenuse can be is the hypotenuse. So the adjacent for angle A is little b over our hypotenuse, which is c. Now, if we look from angle B, so we're looking for the cosine of angle B, adjacent to angle B is little a. So we'd have little a over our hypotenuse, which is c. So we've got our triangle completely labeled now with our hypotenuse and our opposites and adjacents. Again, labeling which angle goes with which opposite and adjacent. And our last trigonometric ratio is tangent. Tangent is opposite over adjacent. So opposite angle A is our little a. Adjacent to angle A is little b. Tangent of angle B, again, opposite it is little b over our adjacent to angle B, which is little a. So all of these are on the formula chart, but once you get into pre-cal, which maybe your next class, maybe 2 classes away for you, you won't have a formula chart with these on them. So you will have to have these memorized. And we have a acronym for that. So CATOA, sum old hippie for sine equals opposite over hypotenuse. Caught another hippie. For cosine equals adjacent over hypotenuse. Taking our apples for tangent equals opposite over adjacent. On example 1, we want to write each trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth. So we need to write our fraction first, and then just type that fraction into the calculator and get our decimal. We do need to label our triangle. Again, always label your hypotenuse first. Our hypotenuse is 13 because it's across from our right angle. And we are looking from angle R to begin with. So angle R is right here. The side next to it is adjacent to it. So that's adjacent to angle R is the 5. And the other side, the one across from it, is our opposite for angle R. Notice how I labeled both of those with angle R to specify that they only go with angle R. So we want the sine of angle R. Remember that sine is opposite over hypotenuse. So we need the opposite of angle R, which is 12, over the hypotenuse, which is 13. So then we need to find 12 over 13 as a decimal. And we're rounding to the nearest hundredth, so we got 0.92. Then we want the cosine of angle R. So we already have our triangle labeled for angle R. And cosine is adjacent over hypotenuse. So we need the adjacent to angle R, which is 5, over our hypotenuse, which is 13. And again, we're going to take this to our calculator, type in our fraction, and get our decimal. Again, we're rounding to the nearest hundredths place, so that's 0.38. And then we're looking for the tangent of angle S. So tangent is opposite over adjacent. And we need to label our triangle from angle S. So next to angle S is our adjacent, that's 12. Across from angle S is 5, that's our opposite for angle S. So tangent for angle S is opposite over adjacent. So opposite angle S is 5, adjacent to angle S is 12. And then we can take that to our calculator. We want a decimal. Rounding the nearest hundredth, so after that 1 is a 6, so we're raising our score. So we got 0.42. Our next set of examples say use the calculator to find each trigonometric ratio. Round to the nearest hundredth. Okay, so every day from here on out, you need to make sure that your calculator is in the correct mode. We need to be in degree mode. So to check that, we're going to go to our home screen and then go to settings and document settings. So from the home screen, setting and document settings, And then we want to go to angle, and you need to have degree, and you need to make that your default. And then press OK. Now, if you're on an Inspire, up here in the corner, it'll say degree. If it does not say degree, that means you are in the wrong mode and you need to change it, just like we just did, going to your home screen, going to settings, going to document settings, angle, degree, and making it your default. Now, if you are on a computer, you will need to change your calculator to look something like this, which means you need to have it in scientific mode. So up here in the left-hand corner, instead of being in standard, which is just your 4-function calculator, you need to be in scientific. And then you need to make sure that you have degree selected up here. And under trigonometry, type in your number, and then your trigonometric ratio. And the sine of 30 should get you 0.5. It's your way to check it. If you have a phone for a calculator, you will want to flip it from going this way to sideways, and that should turn on your scientific calculator. And show you your sine, cosine, and tangent like that. Okay, again, you want to make sure that it's in degrees. So check the sine of 30 and make sure you get 0.5. Because if you're not in degree mode, it will give you something else, which you'll talk about in pre-cal. So we want to use our calculator and find the cosine of 76 degrees. So on an Inspire, we're going to go to trig and over to cosine and 76. And the degree sign is down here. So just in case you forgot to change it to degree mode, putting in that degree sign makes sure that you're in degree mode. Now there's not a workaround for the cell phone or the computer one. So you have to be in degree mode for both of those. Again, double check sine of 30 should get you 0.5. So cosine of 76 degrees, and we're rounding to the nearest hundredths place, is 0.24. Now we're going to take the sine of 8 degrees. So trig sine and 8 degrees. And we're rounding to the hundredths place, so we get 0.14. I'm going to show it on the computer one again. So this time we want tangent of 82 degrees. Again, make sure that you're in scientific. Make sure you have degrees. And we want 82 degrees. So you type in your number first, and then go to trig and which one you want. And we want to the hundredths place, so that's 7.12. Next up, we want to find the given lengths. So we are looking for AB. So I'm going to put an X on AB because that's what we're looking for. And then we need to label our triangle. First off, I'm going to highlight the angle that we're looking from. So we're looking from that 41 degrees. Across from a right angle is our hypotenuse. That doesn't change. It's always across from your right angle. We're looking from that 41 degrees. So next to it, that's not our hypotenuse, is our adjacent. And across from it is our opposite. So when we choose the two sides that we need to use, we always need the side that has a number. So we need that 6.1. And we need the side we're looking for, x. So always our variable and the side that has a number. And it's the number that's given to us in the problem. So we have opposite and adjacent. So remember that our trigonometric ratios, we have sine, which is opposite over hypotenuse. So we're not going to use that one because we have opposite and adjacent that we need. We have cosine, which is adjacent over hypotenuse. Not going to use that one either because we have opposite and adjacent. And we have tangent. Tangent is opposite over adjacent. We are going to use that one. So it's tangent of our angle measure, 41 degrees, over 1. So it doesn't matter if we have sine, cosine, or tangent here. It's always going to be over 1 equals our opposite, which is 6.1 over x. And then we're going to cross multiply and solve for x. So when we cross multiply, that gives us x times tangent of 41 degrees. Now I put this tangent of 41 degrees in parentheses because it is one whole number. You can't divide out the 41 from tangent. You can't divide out the tangent from the 41. It is one thing. Equals 6.1. So we want to get x by itself. So now we're going to divide by tangent of 41 degrees. And then we're going to go to our calculator and type in 6.1 divided by tangent of 41 degrees. So on an Inspire, control divide, 6.1 divided by tangent of 41 degrees. And we are rounding to the hundredths place, so we have 7.02. If you are on a computer calculator, we're going to type in that 6.1, then press divide, and then we're going to type our degree measure, 41, and then our trigonometric ratio tangent, and press equals. Our next one, we are looking for the length of MP, so I'm going to put X on MP because that's what we're looking for. And then we're going to label our triangle. You need to make sure you are labeling your triangle every time. So first off, we label our hypotenuse. Our hypotenuse is across from our right angle, and that's 8.7. And then we are looking from angle N. It's the angle that was given to us. It's at 20 degrees. So next to angle M is our adjacent. Across from angle N is our opposite. Remember what I said on our last problem? The two sides that we use are the side with a number. So it's our hypotenuse, and the side that we're looking for, the one with our variable. So that's our opposite. So which of our trigonometric ratios uses hypotenuse and opposite? Sine. So we're going to take sine of our angle measure, 20 degrees, over 1. Again, always put it over 1, equals Sine is opposite over hypotenuse, so opposite is x over hypotenuse, which is 8.7. We have our proportion set up now, so we are going to cross multiply. So we have 8.7 times sine of 20 degrees equaling x. So we've got x by itself, so we're going to just take this to our calculator. So on an Inspire, just type it in, 8.7 times sine of 20 degrees. And we're rounding to the nearest hundredths place. So after that 7, we have a 5, so we are rounding up. So that gets us 2.98 centimeters. So if you are on a computer calculator, type in 8.7, then times your degree measure, which is 20, and then sine, and press equals. And we get the same answer. Next up, we are looking for YZ. So YZ is what we're looking for. And then we need to label our hypotenuse. Our hypotenuse is YZ, it is what we're looking for. And then looking from 38 degrees, because that was the angle that we were given, we need to label the rest of our triangle. So next to that 38 degrees is our adjacent. Across from it is our opposite. So again, remember, we need our side with our number. So we have our adjacent, and we need our side that has our variable. So we have adjacent and hypotenuse, which gives us cosine. So we're going to use cosine of our angle measure, which is 38 degrees, over 1 equals our adjacent, which is 12.6 over x. And again, we're going to cross multiply. And that gives us 12 times cosine of, or x times cosine of 38.6 equaling 12.6. And then we're going to divide by cosine of 38 degrees. So into our calculator, we're going to type 12.6 divided by cosine of 38 degrees. And rounding to the nearest hundredths place, we get 15.99. And our next example, a contractor is building a wheelchair ramp for a doorway that is 1.2 feet above the ground. To meet ADA guidelines, the ramp will make an angle of 4.8 degrees with the ground. To the nearest hundredth of a foot, what is the horizontal distance covered by the ramp? So I redrew the triangle because I can't draw in that little bitty triangle. So we have 1.2 feet above the ground, 48 degrees with a horizontal. And the horizontal is this, it's what we're looking for. So we're going to label our figure. Again, hypotenuse first, it's across from our right angle. And we have 4.8 degrees here. And right next to it is our adjacent. across from it is the opposite. So again, we need our side that we're looking for and the side we have a number for. So that means that we are going to use tangent because we have opposite and adjacent. So tangent of 4.8 degrees over 1 equals our opposite, which is 1.2, over our adjacent, which is x. And again, we're going to cross multiply. So we have x times tangent of 4.8 degrees equaling 1.2. Divide by tangent of 4.8 degrees. So to our calculator, we are going to put 1.2 over tangent of 4.8 degrees. And again, rounding to the nearest hundredth of a foot, 14.29 feet.